Good morning. Today I shall discuss few more questions and answers on the topic of short question and answers for some uh, examination. More especially for young engineers who are job aspirant and some are interested to get uh, accommodation in good institution for higher studies. For their request, I am presenting all these short videos. I have already uploaded 3 videos and this will be the next video. In this context, I would like to add here that these questions may or may not be directly appear in question sheets, but this type of short questions are generally found in those competitive examinations. If anyone thoroughly go through any textbook, then he can easily understand the answers of any questions. Normally what I seen comparing some several years questions and questions of different examinations for GATE and UPSC and state services. I saw this type of sort very small question they are asking, that which does not require any sophisticated study or any expertise to reply this if anyone has thorough enough of his textbook. Beyond textbook, no questions are seen. All are in textbook. In same light, I am preparing all these short videos for your purpose. I shall be happy if it is some useful to anyone, then I shall be remain grateful, and it shall be my great pleasure. One more important aspect I am adding here, that there are innumerable typing mistake or printing mistake, whatever it may be, which I am not able to edit or correct. As I am looking forward to your active cooperation and to bear with me. Today I am starting part 4. Question: a 4-storied building was tilted and differential settlement of 150 mm was noticed. 4-storied building, after construction, after few years, differential settlement of 150 mm was noticed. The building, another condition is that the building cannot be demolished due to several adjacent buildings. These adjacent buildings was there. The building was resting on timber pile foundation. So this building, having a differential settlement of 150 mm, resting on timber pile foundation. What shall be safe proposition to restrict further settlement? Answer is demolish up top story, ground improvement, pile foundation at periphery, pile foundation at periphery, enlargement of pile cap to behave like footing foundation, none of this. After detailed study, it was found that pile foundation is periphery, is the correct answer. Pile foundation at periphery. Pile foundation at periphery. Because you see, if we are going to provide enlargement of pile cap for changing the difference of foundation system, we have to excavate up to the pile cap level, then it may create another problem since overburden pressure will be released and we cannot go for demolish of top story. Then no one can give assurance that there shall be no other bad impact on the buildings. So it is better to provide additional pile foundation at periphery and connected with the present building. A double-story building was constructed at about 70 years back, which was in all respects safe. His son, in second generation, his son has constructed a new 3-storied building at about 4 meters away from the old building. After completion, gradual settlement notice. Both buildings are now inclined one above other. What may be reason? Answers as poor design of both the buildings, soil condition is very poor, stress overlapping of adjacent foundation, old building and a new building, different loading system, none of this. See, poor design, we cannot solve the poor design of the buildings because the life of the old building is 70 years, no such settlement is reported, soil condition is very poor, it was not agreeable since old building, life is the old building is 70 years. So the main region of settlement is stress overlapping of adjacent foundation. Stress overlapping of adjacent foundation, because buildings are closely spaced. Difference is 4 meters. 4 meters means at least 2 meters from this building. Foundation will be going out minimum 2 meters to 3 meters from this side, and that other building from other side there will be 2 to 3 meters this side. So there is a stress overlapping. So that point is heavily loaded, and soil strength is any soil strength when there shall be different loading, almost double the loading, there shall be settlement. In Barak Valley, most of the buildings are resting on reconditioned soil, ground improvement by bamboo piling. Bamboo is a biodegradable material. As such, is it advisable? Answer is not advisable. Advisable below water table. Mature bamboo is not at all biodegradable. For temporary structure for a short period, these are suitable. Structure may collapse at all of a sudden. Says most of the towns of Barak Valley, 3-4 stories building, but formation soil of Barak Valley is carbonaceous shale origin. In present situation, these are behaving like CH, highly plastic clay, but origin is carbonaceous shale. So, soil condition is not so good enough. Up to 5-6 meter soil condition is not good enough. So, it is advisable for soil for ground improvement by bamboo nailing or bamboo piling. Below water table, advisable. Below water table, mature bamboo is not at all biodegradable. In rock bed RQD, rock quality designation is an important identification of strength of rock mass. The SBC, shape bearing capacity of rock, generally calculated out from initial compressive strength, which we normally call UCS, and discontinuity factor, discontinuity spacing, discontinuity thickness. Discontinuity factors is discontinuity spacing and thickness of discontinuity. In such cases, what is the role of RQD, rock quality designation? There is an empirical relationship between RQD and SBC. There is a correction factor of SBC using RQD. For preliminary estimation of SBC, RQD is a rough information. None of this. There is an empirical correct answer is there is an empirical relationship between RQD and SBC. Basically, when RQD is on higher side, the hardness of rock is increasing. That means shear strength of rock mass is higher. RQD based on joints and flexures. More the joints, less the RQD. So, it will give us in before this present IS present IS 12070, before that publication of that IS standard 12070, that is standard, earlier the SBC was calculated out from RQD value itself. Since there is no other method, correct answer is RQD has an empirical relationship with SBC. SBC of block bed was calculated with safety factor of 12 as 1 MPa against a settlement of 4 mm. After construction, height of the superstructure required to be increased, resulting in increase of loads on foundation. In such cases, how much SBC can be increased without violating the IS clauses? 1.5 MPa, 1.5 MPa, 2 MPa, 3 MPa, no further increment. None of this. You see, in rock, our permissible settlement is, as per IS code, our permissible settlement is 12 millimeter. 12 millimeter. So here we are getting 2 millimeter, 4 millimeter, and these are based on elastic modulus, stress strain relationship. From the stress and strain relationship, this SBC generally calculated as per IS provision. So in such cases, it is almost when SBC is increased, settlement shall be increased, and when it is increasing from 1 to 2, then it will be 8. When it will be increasing 1 to 3, then it will be 12. Since 12 is our permissible limit, we cannot proceed more than 12. So considering 12 millimeter settlement, we can go for high increment of 3 MPa, and we cannot cross this limit. This is the permissible limit of 3 MPa. If it is settlement is 1 even against pressure of 1 MPa, in such case also we cannot cross this limit 3 MPa. 3 MPa is the last permissible limit of SBC of rock. A sound bedrock having SBC of 2 MPa, after due consideration of discontinuity and RQD, against a settlement of 2.5 millimeter. During construction, it was observed that the discontinuity thickness initially, although very thin, micromillimeter, but at the lower end it was found as 10 centimeter. It is greater than 10 centimeter thickness of discontinuity. Further, the discontinuity was at slope. Now, what inference can be drawn? SBC should be checked again considering discontinuity as 10 cm. Discontinuities should be filled with some rich cement ground under high pressure. Rock bolting of the foundation. Foundation shall be provided at further lower depth. Lower depth means deeper depth. Further lower depth means deeper depth. And none of this. In this condition, best option is discontinuity should be filled with rich cement grout under high pressure. When it will be grouted, all the grouts shall be penetrate the discontinuities and shall remove all the debris and some least material, least LEACHED, least material, and the foundation rock shall behave like monolithic rock having RQD nearer to 100%. When there will be no joints, there shall be no discontinuity, and SBC shall be increased accordingly. A structure was designed for a load of 1 MPa against a settlement of 6 mm. During construction, due to revision of IS code, the total load expected to be increased tremendously. Under this situation, up to what extent loading can be increased? Loading can be increased safely under codal provision 1.5 MPa, 2 MPa, 2.5 MPa, 3 MPa, none of this. Here you see load is 1 MPa. Load is 1 MPa and settlement was 6 mm. We are having only those, but if it is rock, yes, we can increase. If it is pre-consolidated hard soil, we can increase. If it is normally consolidated or loose sand deposits, we cannot increase at all. So, answer is none of this. Since these informations are not furnished here, this last answer is answer number 5, none of these. An anticipated settlement of 2 meter by 2 meter footing on bedrock for a pressure intensity of 1 MPa has been worked out as settlement of 2 mm. Settlement of 2 mm. Here one word was missing as settlement of 2 mm. If the foundation size was increased to 4 meter by 4 meter with same pressure intensity of same rock bed, what shall be the settlement? Here question you see, foundation size is 2 meter and pressure intensity is 1 MPa and settlement is 2 mm. So, because of increased load 4 meter by 4 meter and pressure intensity is 1 MPa, what shall be the settlement? Our question is, what shall be the settlement? Since it is a bedrock, our permissible limit is 12 mm and we know the base is almost double. Base is almost double. When base is almost double in rock, it is P by B, PB, and other factors are there, stress-strain relationship, that is Poisson ratio and elastic modulus. Those factors are same word, same rock bed. So those factors are constant. Only pressure intensity also constant. Only foundation size is changing from 2 by 2 meter to 4 by 4 meter. So it is straight answer shall be double. This 2 meter divided by 2 millimeter divided by 2 multiplied by 4. It is arithmetical proportional. It is, answer is 4 millimeter. Oh, answer is 4 millimeter. It is known that fine-grained sand is derived from disintegration of rock due to rock weathering. But at the same time, it is considered that rock masses is completely free from scar. The rock may transform to fine-grained sand in future. Why rock is considered as inerodable? Given answer, weathering from rock to fine-grained sand required millions years, and the life of our design structure is about 100 years only. As code recommended, rock has permanent bondage. Rock particles has permanent bondage. What is the difference between soil and rock? The rock compositions, rock materials has permanent bondage, but the soil particles has no bondage, no permanent bondage. Rock has permanent bonding capacity. Rock is not friable. Rock and soil is totally different. None of this. Here you see, this is a generally it is, although it is technical terms are there, engineering terms are there, scour, these are technical terms are there, but it is general conception. All fine-grained sand derived from rock weathering. All soils are derived from rock weathering. Initially it became boulders, then it became cobbles, then gravels, then coarse sand, then fine sand. Repeated stages of the weathering. And weathering from rock to fine-grained sand required millions of years. And the life of our design structures is 100 years only. We are designing not for not more than 100 years. Some ancient monuments, Qutub Minar, Taj Mahal, these are exceptional cases. And at present, their survival became survival process. So this existence no one can deny, but we cannot design more than 100 years with the present system of all working conditions and other conditions, materials, all everything. Next question is, generally RCC structures, superstructure, substructure and foundations in design using the same analytical procedure except foundation sizes for soil and rock, which depends on SBC only. If for RCC structure on soil 60 millimeter settlement can be allowed, why we cannot allow more than 12 millimeter in rock? Given answer is at 12 millimeter rock shall crack down. Rock has a sudden failure tendency in a fraction of a second. settlement of rock is not gradual. Settlement of soil is very slow and gradual. None of this. You see, soil and rock is a completely of different nature. In concrete, steel members are not friable. All steels give us sufficient information. So gradually there will be some amount of tension. It gradually shear. But the concrete failure is all of a sudden. Like that, rock has a sudden failure tendency in a fraction of a second. If you are testing rock mass in laboratory, you can easily observe the lowest strain diameter no one can record. Whatever it may be, digital or something else, lust, it is taking stress continuously. It is taking stress at a nominal moment of strain. Stress is taking, and suddenly it will fail down. There will be shear. So rock has a sudden failure tendency, like concrete. So we cannot go for 60 mm. In rock, you see, in SBC, minimum 6 SBC we are providing. In SBC analysis also 6 to 8 safety factor generally used. Some cases it is 12. And settlement, here in clay, some cases it is 60, in some cases in 75, like that. But in rock, it is 12 mm only, because rock has a sudden failure tendency. What type of drilling is suitable for sampling of rock samples for laboratory issues test? Given answer is diamond core drilling, slowly under nominal pressure, percussion drilling, rotary mud drilling, standard penetration test. None of this. The best option for getting good quality core for ECS laboratory ECS test is diamond core drilling. Slowly under nominal pressure. Pressure shall be very nominal and slowly. We should not be hurried. Slowly we can get very good quality specimen, test specimen. Percussion drilling, you can make the hole only, you cannot get core. Rotary mud bore, in some cases some core was blocked with mud circulation. Since it is there are sometime the RQD became very less during sudden shear inside the barrel itself. And SPT, it cannot be penetrated about 1 centimeter or 2, more than 1 centimeter or 2 centimeter, like that. So diamond core drilling under nominal pressure is best for getting suitable core for laboratory ECS test from rock bed. In a building project, 22 foundations out of total 35 foundations are resting on dense, compact, well-graded gravelly sand. Soil type is GW/SW. Having SBC of 25 ton per meter square. That is 2.5 kg per cm square. And rest 13 foundations are resting on hard intact rock with SBC of 100 ton per meter square. Now accordingly foundation design has done. Maximum pressure intensity of soil portion is calculated as around 22 ton per meter square, while in rock portion the maximum pressure intensity is 60 ton per meter square. The differential settlement between the foundation between soil and rock has been calculated as 1 in 600. Whether any further precaution is necessary or building is safe. Special given ensure is special precaution is necessary. Building is safe. Expansion zones in between soil and rock portion is essential. There is a sense of liquefaction of sand deposit. None of this. You see, this important criteria here it is differential settlement 1 in 600. This is differential settlement. Another is pressure intensity of it is 100 ton for rock and 25 ton for soil. And after distribution of load, it is 60 ton for rock and 22 ton for soil. This is also a safe, it is less than 100. This is also a safe, it is less than 25. And only there may be difference of settlement. Since one portion is rock, other portion is soil. So differential settlement is 1 in 600. Our maximum permissible limit is 1 in 400. If the permissible limit is 1 in 400, it is 1 in 600 is smaller than that limit. So building is safe. Undoubtedly building is safe. At IIT Guwahati complex, a few buildings are located and at intact fresh hard gneissic rock. Due to poor to fair RQD, the foundation was designed at 1.5 meter below rock bed level. During construction, more than 2 years were required for blasting of gneissic bed. By that time, blasting explosive was banned in northeast India. In this critical situation, what can be done keeping safety of this structure in view? Foundation given ensure foundation may be provided at 0.6 meter below rock level. Foundation may be provided at any depth inside rock mass over uniform sheeting and with rock bolting. A detailed analysis is necessary. Foundation should be provided at 1.5 below as per analysis. Here you see, complication is there are two complications. One complication it became very difficult for blasting. 2 years only for foundation it has been spoiled. So, and when explosives are not available when it is banned item, so it is very difficult to get explosive. Getting explosive may not be difficult, but it will be criminal offense. And another thing is, what will be this? Our basic purpose is building should be safe and it should be workable. So in such cases, ensure number 2, foundation may be provided at any depth inside rock over uniform sitting with rock bolting. That means when we shall provide the foundation at rock, the sitting should be uniform, and for tension load, especially in Zone 5, for tension load, the foundation shall be bolted with rock bed. So this is the correct answer. Foundation may be provided at any depth inside rock over uniform seating with rock bolting. That means foundation should be bolted with rock bed so that there will be no tension problem. Miscellaneous. Since last few years, the people of urban areas, especially Guwahati citizens, facing artificial floods even, and our rainfall. What is the basic reason behind? Improper drainage system. Drains are blocked by plastic and degradable materials. Rainfall intensity is increasing. Global climatic condition. What? None of this. What shall be correct answer? When drainage system should be proper, rainwater will be going out. But here, because of improper drainage system, the water cannot pass. Improper means either slope is not proper, or size of drain is not sufficient to drain out the rainwater, and the outlet, the water, where water was going, that outlet, there may be the water level of that point is little higher. So there are lot of important parameters was there. So these are not properly considered. Improper drainage system. Drains are blocked by plastic. These are all these we are general thing. How much area will be blocked by plastics? And plastic is a lightweight material. When water velocity will be more, then automatically it will be washed away. When a RCC culvert can wash away by water, what is the problem to washing a plastic bottle or something like that? Because of improper drainage system. As stated in A, in this question, as an engineer, what is your opinion to make Guwahati a flood-free city? Given answer is raising the entire city, making more drains, constructing catchwater drain, rainwater harvesting, none of this. You see, I am residing at Guwahati. I am from Guwahati itself. So, raising of entire city is very difficult proposition which can be made in a drawing sheet only. Making more drains, it is impossible. There is no free land for construction of drains. Constructing catchwater drain, We can make it on papers. Rainwater harvesting? Yes. The rainwater, if we penetrate to the underground, if we penetrate the rainwater totally underground, the harvesting, rainwater harvesting, then Guwahati shall be free from all artificial flood. It is out of record. If you have any good solution than this, please let me know so that I can present it to our government. Next question is, the total land area of Majuli, the world's biggest river island, was 1255 square kilometer in 1901, 751 kilometer in 1917, 564 kilometer in 1972, 454 kilometer is 1996, 422 kilometer in 201, and less than 400 in 2016. In case of decrease in land area, mainly due to huge bank erosion by river Brahmaputra, this may be the world's smallest island, even smaller than Umananda at Guwahati. Guwahati, by the end of 2045. As an engineer, do you agree? You see, if we go for a statistical analysis, this is gradually it is decreasing. From 1901, it was 1255, and in 2016, it is nearest to 400, less than 400, and in 2001, in these 100 years, not 100 years, it how much? 90. It is 100 years. During 100 years, it is from 1255 to 422. And during this 15 years, it is decreasing, more decreasing. As an engineer, question is, as engineers, do you agree this? It will be decreasing by the 2045. It will be more smaller than the smallest river island. Umananda is the smallest river island, world's smallest river island. During 2045, it will be became smaller than Umananda. Do you agree or not? Given answer is agree. Another is disagree. Another answer is it shall be stable after attaining regime condition. Another is erosion at site resulted deposition at other site. None of this. Disagree. Given answer is disagree, since hydrological behaviors are not similar to statistical analysis. Because you see, these 2045 was calculated on the basis of statistical data. So, in hydrological behavior, erosion and deposition, these behaviors are not similar to statistical analysis. Not similar, no, it is not statistics. So our answer is disagree, since hydrological behaviors are not similar to statistical analysis. As discussed in C, in this question, if the bank erosion is continuing at this rate, there shall no trace of world's biggest river island by 2050. This is one equation was developed from this graphical representation of statistical data. As an engineer, do you agree? Agree? Disagree? It shall be stable after attaining regime condition, erosion, resultant deposition, none of this. Here also, disagree, since hydrological behaviors are not similar to statistical analysis. Floods in Assam is a major unbeatable problems of the state. It is also lagging far behind than other states of the country. In addition to this, a huge amount is wasted in the name of flood damage repairing work, which results slow development activities. As an engineer, what do you think about the basic cause of the flood? Formation of innumerable sandbars at riverbed. Assam is surrounded by hills, almost all sides, friable loose bank material, heavy suspended load, none of this. If you get a chance to visit Assam, please spend 1 to 3 hours at river bank of Brahmaputra. Even winter also, erosion at banks notice. In flood season, in monsoon, doesn't matter. Even in winter, in dry season, banks are eroded because of friable loose bank material. It has no resistance. Only with the seepage water it can be eroded. During dry season, seepage waters are passing there. Seepage from the river bank. The river bank seepage water is flowing to river. With that seepage water, bank's material is also removed. So friable loose bank material. As stated in E, a program of dredging of river bed has been taken by Government of Assam, especially for reopening of navigation route. Do you feel that this shall be successful in solving the flood control problem in Assam? Given answer is 100% successful to a small extent. Initially 1 or 2 years may be useful, but later on it shall fail. Rockfill river bank only be successful, none of this. You see, as I told earlier, bank erosion is the major criteria for the flood of, because these are carrying silt shards from China to Assam. Long distance it is carrying innumerable rivers, both in Tibet, Arunachal Hills, Nagaland Hills, all rivers are coming from Arunachal Hills, Nagaland Hills, all the Bhutans, these are all coming together and meet Brahmaputra. And all these rivers, these are carrying suspended load. So finally, the required waterway is decreasing. For passing out at a constant velocity will be not increased. At a constant velocity, for passing out the flood discharge, it became difficult. So water is coming up. Banks are inundated and everywhere there are heavy damage. This program of dredging, yes, it looks like good option. When the depth will be the more, but it will be not solution. The only solution is rock-filled river bank only be successful. This rock-filled river bed only be successful. Initially, say one flood season may be safe, may be good, but next year sediment load will be constant, so we cannot restrict the sediment loads. Most of the river where banks are rigid, Khadir, it is Khadir is word of irrigation engineering. Khadir, inerodable bank, permanent bank of river is called Khadir. The stream section is very narrow, for which in that reach normally no sandbar noticed. Considering this phenomenon, if the river bank material transformed to inerodable material, is there any chances of controlling the river erosion? What type of method shall be more appropriate? Artificial rocky bank, reinforced cement grouting, mud concreting, plantation of first growing trees, none of this. We know that when inerodable bank materials are there, then if banks are permanent, then thickness river width shall be generally narrow. So there will be no, in those rivers, sediment loads are very less because of velocity. Velocity is, since both banks are inerodable and it is maintaining bank properly. In this case, if we can convert the river bank, this inerodable to inerodable state, providing artificial some material, reinforced cement grouting at bank or some other materials or some cementing, we can resist the bank erosion. But here, out of all this, best option, artificial rocky bank. If we can dump some boulders and put in some cement grout, then it will behave like monolithic hard rock. So there will be no scour at all. The government of Assam is taking a project of renovation and development works at Nilachal Hill, more especially at a decorated shade over Mekhela Uja Path, the rock staircase which was constructed by King Narak Asur about 10,000 years ago, without any change, alteration, addition, destruction of the existing staircase. The existing staircase, it is rock-cut staircase. By manual cutting, the steps are made. It is more than 900 meter total length of this rock. It is a very steep hill, and its length is 950 meter. The site is so difficult that the left side densely populated and the right side is very steep hill. After a careful observation, it was decided by experts to provide a design as a great beam at each side from bottom to top to support the superstructure. The formation is weathered, jointed and fractured granite bed. For bearing, if found to be provided, is adequate. The bearing capacity is adequate and safe, but there is no scope for foundation. In case of RCC, beams are provided then to arrest slipping of the beam. Necessary rock anchorage shall be required. In case hill shall be disturbed, since in case of any disturbance there may be a heavy landslide. Under these circumstances, what type of drilling is suitable for rock anchorage? Any type of drilling, percussion drilling, rotary core drilling, rotary non-core drilling, none of this. Because can you understand the history? There is a granite bed is there from bottom to top, and at the left side of this staircase, the staircase is rock-made staircase. It is handmade, 950 meter length, and we cannot go for any type of foundation for this proposed light structures. We have to make RCC grade beam from bottom to top, and there is a possibility of slipping of the beams. So beams shall be fixed. There is no other option. We have to encourage the beam with the rock bed. In such cases, what type of drilling is suitable? Because in case of any slightest disturbance, there shall be heavy landslide. Heavy landslide will be there. So here a special type of drilling shall be required. Rotary non-coring. Rotary coring or non-coring, both are same, but non-coring will be little fast, so it will be slightly economy, but the coring will be little costly. So rotary non-coring drilling. A major bridge was constructed at a Boulder River bed. After completion of the bridge, a stone quarry was opened about 200 meters downstream of the bridge for collection of boulders from the river bed. Subsequently, after 15 years, the pier foundation, the two pier foundations was settled down, which cannot be rehabilitated. Why the foundation was settled down? There may be a soft layer below the well foundation, consolidation settlement of the foundation soil during removal of boulders at the quarry. All the boulders rolled down to the quarry site and the bed scar was started near the foundation. Insufficient length of the well. None of this. See, in boulders are almost round in shape. Boulders are almost round in shape. With river velocity, it was rolling down. If velocity will be more, it will be easily rolled down. Since the quarry opened 200 meters downstream of the bridge, the velocity will be decreasing because the velocity shall be increasing because of steep slope. Boulders removed during removal of the boulders from the quarry, there will be some steep slope. Velocity will be increasing. In such condition, during removal of boulders at the quarry, all the boulders rolled down to the quarry site and the bed scar was started near the foundations. So we should not permit at downstream, no such quarry should be permitted at all. At upstream, about 2 kilometers beyond, we can go for boulder quarry. Nowadays, the road blockade due to heavy landslide, especially hilly regions, are almost regular during rainy season. What is root cause of this landslide? Given nature, steep slope, inadequate protection, deforestation, imbalanced rainwater receipt and evaporation, inadequate surface drainage system, none of this. You see, all over India, same thing is happening. Very recently, a lot of landslide was reported in Uttarakhand, in Himalayan ranges. There are a lot of landslide was noticed, and all roads are closed for 2-3 days like that. It is only because of deforestation. If we go back to 1,000 years back, now imagine in 1,000 years back, same river is there, same amount of rainfall was there, but there was no such things are reported. People are going this hilltop on barefoot only. But when our civilization started, we are cutting our plants and everything. We are not going for afforestation. So plants, what is the benefit of the plants? Plants, if you can remember King Ashoka, he has constructed roads and planted both side trees. That time people thought that for the shade, to giving shade and to give shelter for the travelers from rain and sunlight. Yes, maybe that may be one reason, but this root of the plants behave like a reinforcement in the soil. That means the formation is transforming to reinforced soil. Number one benefit, it will resist against landslide. Number two, these plants absorb about 25% of soil moisture. So, natural evaporation system keeping aside, plants will absorb 25% of soil moisture for their own livelihood. So, deforestation, when we make our earth green, all these problems like landslide and road blockage, these are not there. It will be in dictionary only. The word will be landslide will be disappear from our real world. It will be going to words world, dictionaries only. Next question. A residential building was designed with a pile foundation considering a safe load of 60 ton per pile according to pile diameter of 500 mm. During initial pile load tests, the safe load had been calculated as 50 ton per pile. What shall be the best alternative for the shortfall? Given answer is provision of extra pile in group, proportional increase of pile length, proportional increase of pile diameter, revised pile load estimation, none of this. You see, to estimate the safe load, the pile safe load is generated by tip bearing resistance and wall frictions. For tip bearing resistance, when it was designed for 60 ton of 500 mm dia, and during test it is get 50 ton. So considering this diameter and length, we do not know what is the length. We cannot say that if we increase the proportionally length for 50 ton, this is length, and 60 ton, this is length, this will be the length. We cannot say in this way. Just mathematical proportional increment of length shall not give you required load, because there are all factors, there are a lot of factors are there. So the 20 times diameter factor will be coming, all these parameter will be coming. So it is better to provide proportional increase of pile diameter, because our depth will be same. Our pile load will be, when 500 mm diameter give you 50 ton, if we increase to 600 mm, we will get 60 ton. Straightway we should go for proportional increase of pile diameter, because since all other factors are same. In our country there are two types of structure: properly designed with poor workmanship and poor quality materials, and poor design with good workmanship with good quality of materials. Which is suitable? Properly designed with poor workmanship and poor quality of materials, or poor design with good workmanship with good quality of materials? None of this. You see, finally in our design there are lot of safety factor we are considering. If good quality work with good quality materials, poor design is good with best for, then good properly designed with poor workmanship and poor quality of materials. Instead of this, it is more better poor design with good workmanship with good quality materials. It shall be the, so it is more important to give proper intention in workmanship. As I am speaking with my beloved young engineers, my humble request to all of you, that we should give proper attention to good quality and good workmanship, then our design is coming. India had been experiencing many major earthquakes since time immemorial. Scientists are also claiming that the Himalaya under sea for million years back. Is there any specific theory to predict time and place of occurrence of such major earthquake? What is the base of this theory? No such theory. Given answer is no such theory for prediction of earthquake so far established. Statistical data analysis, no one can predict so far, none of this. We know we are always afraid of earthquake. Nepal earthquake, Imphal earthquake, Bhuj earthquake. There are a lot of major earthquake in our country and heavy damage of our property and our nature too. And our scientists are always saying that is especially for the northeast where I am residing, where I am living, that there may be always in newspaper always I am reading one scientist say that there are all possibilities of major earthquake coming soon in northeast India, and there are all possibility of major earthquake. But nobody says it where it will be coming, whether in Assam or Gujarat or Delhi or Bombay or Madras, Chennai, where it will be coming, no one can say. If scientists can give proper information, then during that time, at least 15 days, we can go outside the state. Why? But they are saying that there are possibilities of major earthquake. When and where? If it is sure that the 15 August 2025 at 12 am, then we can go by 1st August out of state. We can go to Bombay or Goa or somewhere else. That will be a holiday trip and safety against earthquake. You see, statistical data analysis is not a proper prediction and system of earthquake. No one can predict so far. Scientist has no prediction theory so far developed. And here I want to add one thing. Earthquake doesn't kill anybody. But our panic kills ourselves. Earthquake never kill anybody. Earthquakes are not interested to taking lives of someone. But our panic make our dreadful and fearful. In this chapter, today, I have finished this topic so far, and I sincerely hope that if you go through these 4 videos, specially preparing for you only, those who are request me or advise me to upload some question and answer for their specific purposes, I am doing this, and I hope it may be useful to you. But I am not sure that this question will be coming directly or not not. But this type of question, there are 100% possibilities of facing this type of small questions which we do not notice while we are reading a textbook. While we are reading a textbook very carefully, even this type of small things we did not notice. So I request everyone to select one textbook and read that textbook very thoroughly. Then ultimately you can able to answer all of any questions. Thank you. Wish you all happy and nice day, and my best wishes shall be always to you for all well at life. And if necessary, if you feel necessary, please mail me. I am always available at jcgogoi @gmail.com. jcgogoi@gmail.com. I am writing here jcgogoi at gmail.com. You can contact me. This is my mail ID. You can contact me, and just if you for some query or thing, any more specific requirement, you may contact me at this mail ID. I am always available at my place. Please, again, my best. Have a nice day. My best wishes always with you.